Dear ladies and gentlemen, today I'm going to present you the features of the automatic diagnostics of the Dream software. So the Dream software measures some spectra of the vibration of the rolling bearings, gearboxes, etc. For example, here we have an envelope spectrum of the vibration of a bearing in a gearbox. We have measured 3 spectra, and we are going to make diagnostics of the condition of this bearing. To do this, of course, we can find some lines and some frequencies, but in Dream software you can do a different thing. You select a measurement and then you press a button that is automatic diagnostics. We enter the rotation speed and press enter. This is a diagnostics. So the program automatically tells you that there is no reasonable forecast for the good condition for this bearing, and we have mainly the cavities or spallings on inner race. That is a very severe defect with very high probability. So here we see some harmonics of the v.5. This is ball pass frequency on the inner race. Some of them are modulated by the rotation speed, and all these lines are classified, and you can look at them in the spectrum. So this is automatic diagnostics. The only thing we did, we tell it what is the bearing dimensions or the bearing model and what is the rotation speed. As for the report, you can look the report at the diagnostics folder, and this will be presented in a table way that we have some recommendations that inspect the bearing, and we have all the spectra and all the lines here in the spectra as the symptoms for this defect. We can also look at the picture, and this is the exactly picture of this very bearing that had a crack in the inner race. So the diagnostics was correct. We can look at another spectrum like this. We have quite a envelope spectrum and auto spectrum, and again, instead of dealing with the lines and frequencies, you can go to the automatic diagnostics mode, enter the rotation speed, press enter, and here is your diagnosis saying replace the bearing. We have cavities, spallings also on the inner race, severe defect. We can look again at the picture from in this database, because this is from some real machines, and this is the defect in the bearing in the inner race. This is also a crack of 2 row bearings. For different examples, we can see another spectrum. This looks like the same a little bit, but we can do the diagnostics again in automatic mode, enter the rotation speed and get the diagnosis. Make visual inspection, so no good forecast, defect on spallings on the outer race, plus we have some defects on another axis in this gearbox. All of them are severe defects, and we can say that this is for cavity spallings of on the outer race, and this is for defect on another axis. Again, we can see the report in the diagnostics folder here. We can see the complete report, including the recommendations and all the defects with all the symptoms that you can print and store for your analysis. We can also look here at the picture. Yes, we have a crack on the outer race here. Take another spectrum, and this is also a spectrum like looks more or less similar, and we have auto spectrum and envelope spectrum. What we do is we do automatic diagnostics, enter the rotation speed, it's much different here, and say OK, and we have replaced the bearing because of these lines, and plus we have some alignment problem because of these lines. Also, you can see the picture. If we go to the user map in the database, we have a database with some pictures. Not this one, but it is, I think that this one. Yes, this is a crack on the rolling element. For the examples of the cage, what we have seen before this, we can also see the envelope spectrum, we can see auto spectrum. This is again the spectrum of the gearbox, and this is the gear mesh frequencies in the auto spectrum. We can go to the automatic analysis, okay, and we see that we have rolling elements and cage problems because of this FTF, or fundamental train or cage frequencies, and we have a problem with the small gear in this gearbox. It is because of these lines. This is gear mesh frequencies modulated by the rotation speed of the corresponding shaft. And we have seen this picture already. Now we can see another one. This is also envelope spectrum. This is envelope spectrum, auto spectrum till 100 Hz, and auto spectrum till 600 Hz. We can take any result, we go for the diagnostics, and we see also that we have a problem with this bearing, and the main is rolling elements and cage defects. Actually, this is a cage defect because of a number of fundamental train frequency. We look at the low frequency spectrum, and here are the lines of the FTF. If we will look at the picture of this bearing, we will see that we have quite a disassembled cage in this bearing of an electrical drive motor. Not only bearings, of course, are subject for diagnostics. We can take some diagnostics of the motor. This is quite a small motor, something like 200 watts motor, and if we go for the analysis for this motor, we are measuring a few spectra. This is auto spectra, this is in radial direction, in tangential direction, and low frequency part of this spectrum. To make the diagnostics, we again press button, enter the rotation speed. Actually, we may not enter it if we did not measure it. You can just leave it empty, and the program by the spectrum will automatically find the rotation speed. So here is the rotation speed that it finds. Also, it finds a squirrel cage defect. It means that medium, not very high one, but still medium, and this is a broken squirrel cage or some damaged squirrel cage. It is diagnostics is made by the split of this rotation speed. This is the first harmonic of the rotation speed, this is the second harmonic of the rotation speed, and the third harmonic of the rotation speed. You see all of them are split into many lines. We have some modulation, and this is the squirrel cage defect. Of course, we can look at the diagnostics folder and have the report about these diagnostics. So we have found a squirrel cage defect. These are the lines, and these are the spectra that show it. Take another motor. This is also induction motor, and we can go for the analysis. We see a picture like this in the spectrum in radial direction, tangential direction, and low frequency. In the low frequency, you see that this is the rotation speed, and it is just a single line without any sideband, so we can immediately say that the squirrel cage is okay. But we can make diagnostics of the other parts of the motor. We enter the rotation speed, and this is the diagnostics. We have static and dynamic eccentricity of the air gap that is stated by this very spectrum, and this is the diagnosis. Static eccentricity of the air gap. Static eccentricity of the air gap is the problem that the rotor is not properly aligned to the stator. So the clearance, usually at the bottom of the stator, is smaller than on top of the stator. Usually this is a problem of bearing wear, and the rotor just goes a little bit down inside the stator. Here is the also distortions of main supply that also can be seen from the vibration of the machine. So this is a typical static eccentricity of the air gap that is slot pass frequency modulated by 100 Hz. The first slot pass frequency, the second slot pass frequency, and the third one. All of them we can see in the spectrum. The next motor that I have in this database, this is suction motor. from the suction pump. We can do the same, go for the diagnostics, enter the rotation speed, and here we have dynamic eccentricity of the air gap. It means that either we have a big misalignment, or we have some bent shaft, or we have some other problems of the installation of the rotor on the shaft, and the minimum clearance rotates with the rotation speed. So here is the spectrum, and here is the automatic diagnostics. Of course, you can look the same at the diagnostics folder, and here is the diagnostic report with all the frequencies marked. This is for this motor, this is for another motor. We have all the diagnostics with all the spectra, all the frequencies and vibration levels marked. So this how the automatic diagnostics of Dream works. Thank you very much for your attention. See you in the next series of this training material. Thank you.